Hello everyone and welcome to AWS Certified Cloud Practitioner course. This lecture will contain all these topics. What is cloud computing? Benefits of cloud computing. Types of cloud computing. Types of cloud computing: public cloud, private cloud, hybrid cloud, cloud computing with AWS, AWS global infrastructure, global infrastructure of AWS cloud, AWS regions and availability zones, North America region, AWS local zones, AWS wavelength, AWS outpost, AWS points of presence, Amazon CloudFront global edge network, cloud security at AWS, AWS cloud compliance, and accessing AWS services. What is cloud computing? Cloud computing enables the delivery of compute power, storage, and other IT resources via the internet on demand, which allows users to obtain resources as needed without long-term commitments. This model allows users to pay only for the IT resources they consume, avoiding the cost associated with the unused capacity or over-provisioning. Users can quickly provision the type and size of resources they require for any project or application, providing the agility to respond to changing business needs. Cloud computing removes the need for large initial investment in physical hardware and the ongoing burden of managing this hardware, shifting the focus to innovation and development. The cloud offers a comprehensive range of services, including servers, storage solutions, and databases, all accessible over the internet for a variety of applications. Through web applications, users can easily provision, manage, and scale resources provided by a cloud services platform like AWS, which manages the underlying hardware. Benefits of cloud computing: instead of large upfront investment in data centers and servers, cloud computing allows you to pay only for the resources you use, making expenses variable and directly tied to your consumption. With cloud computing, you benefit from the aggregated usage of hundreds of thousands of customers, leading to lower cost due to providers like AWS achieving significant economies of scale, which in turn offers lower pay-as-you-go prices. Cloud computing removes the need to predict infrastructure capacity needs. You can scale resources up or down as needed with minimal notice, avoiding the cost of unused resources or the challenges of limited capacity. The availability of IT resources with just a few clicks reduces the time from weeks to minutes to make these resources available to developers, which significantly enhances organizational agility and lowers the cost and the time of experimentation and development. Cloud computing enables you to focus on innovating and serving your customers rather than on the infrastructure necessary to run your business, by eliminating the need for racking, stacking, and powering servers. Deploy your application in multiple regions around the world quickly and easily, providing your customers with lower latency and a better experience at a minimal cost. Types of cloud computing. So there are three types: public cloud, which includes like AWS, Google, Azure, and then we have private cloud, which is on-premises, which is directly maintained by companies. And thirdly, we have hybrid cloud, which is a mixture of public and private. So let's go through the public cloud first. So this is fully deployed in the cloud. Applications run entirely on the cloud infrastructure. This includes apps either built in the cloud or migrated from existing infrastructure to leverage cloud benefits. Cloud applications can utilize low-level infrastructure or high-level services for abstraction from core infrastructure management. Next type of cloud is private cloud, which is on-premises. Resources are deployed on-premises using virtualization and resource management tools, providing dedicated resources without many cloud computing benefits. This model aims to increase resource utilization through application management and virtualization technologies, resembling legacy IT infrastructure. Then thirdly, we have hybrid cloud, which connects cloud-based resources with on-premises infrastructure, extending an organization's infrastructure into the cloud and linking cloud resources to internal systems. Hybrid deployments are common for organizations looking to expand their infrastructure while maintaining a connection to on-premises resources. So cloud computing with AWS. AWS, world's most comprehensive cloud. So AWS offers a broad cloud service coverage globally, serving millions of customers. Over 200 fully featured services. So from data centers worldwide, AWS provides a vast array of services in various domains. Most functionality across technologies. AWS leads with the highest number of services and features, including AI, ML, analytics, and IoT. Deepest functionality within services. Offers a wide range of purpose-built databases for optimal cost and performance. Largest community of customers and partners. Millions of active customers and tens and thousands of partners across all industries. Most secure cloud computing environment, designed to meet the highest security standards, supported by comprehensive security tools and certifications. Fastest pace of innovation. AWS continuously introduces new technologies such as AWS Lambda for serverless computing and Amazon SageMaker for machine learning. Most proven operational expertise. Over 17 years of operational experience, providing mature, reliable, and secure cloud services to a broad spectrum of customers. AWS Global Infrastructure. And so AWS Global Infrastructure contains, first, 33 launched regions, each with multiple availability zones, AZs. Total of 105 availability zones and counting. 600 plus points of presence and 13 regional edge caches. 38 local zones, 29 wavelength zones for ultra-low latency applications. 245 countries and territories served. 115 direct connect locations. So global infrastructure of AWS clouds. So we'll go in some more details. AWS cloud infrastructure is structured around regions and availability zone, with each region being a specific physical location around the world that houses multiple availability zones or AZs. Each availability zone comprises of one or more discrete data centers, ensuring isolated and secure environments within the same region. These data centers are equipped with redundant power supplies, networking, and connectivity to ensure uninterrupted service and reliability. The architecture of having multiple availability zones allows for the deployment of highly available, fault-tolerant, and scalable applications and databases, surpassing the capabilities of a single data center setup. So next is AWS regions and availability zones. Each region are physical locations around the world where data centers are clustered. Each region consists of groups of logical data centers known as availability zones. Every region contains at least 3 isolated and physically separate AZs within a geographic region or within a geographic area. Unlike other providers with single data center regions, AWS multiple AZ design offers significant benefits for reliability and fault tolerance. Each availability zone operates independently with its own power, cooling, and security to ensure uninterrupted service. AZs are interconnected with redundant high-speed networking, enabling ultra-low latency communication. Customers can design their applications to run across multiple availability zones, achieving greater fault tolerance and high availability. So here is a picture of all the 33 active AWS regions. Red dot denotes the region that will come soon. So currently it's 33 and counting. So red ones are the upcoming ones. Next in this picture we have North America continent, which has 8 regions. So these are the regions. So this is another example, and in this diagram Asia Pacific has 9 regions, and the red dots are the regions which are coming soon, and in this case it's Malaysia and Thailand. So these one are the upcoming ones, and these are the 9 other regions. So regions, this is spread across this whole Asia Pacific continent, this whole area, and this, as you can see here, it's spread out in Japan, India, China, and other Singapore and other locations also. So next I'll be explaining the availability zone. An availability zone consists of one or more data centers equipped with redundant power, networking and connectivity. So the point to remember is one availability zone is consisting of multiple data centers. It's not just one data center. So it's always one or more. So most of the time it will be 2 or 3 for high availability and fault tolerance. AZs enable running production applications and databases with greater availability, fault tolerance and scalability than possible in a single data center. AZs within a region are linked by high bandwidth, low latency networks with fully redundant dedicated metro fiber. All network traffic between AZs is securely encrypted, ensuring data privacy and security. The network's high performance supports synchronous data replication between AZs, facilitating real-time data availability and disaster recovery strategies. AZs are physically separated by a significant distance to provide isolation from local disasters like power outages and natural catastrophes, ensuring overall resilience. So this is North America region. So we have seen there was around 7-8 region in the North America continent, but now we are seeing within a region we have for US East 1 we have 6 availability zone, and you can see some information when it was launched and how many local zones it has and when those got launched. So other information is also there, so you can pause the screen and take a look. So next I will be discussing local zone. So what is local zone? AWS local zones bring essential AWS services geographically closer to end users to minimize latency. They are perfect for running applications requiring single-digit millisecond latencies such as media content creation, real-time gaming and machine learning. Each local zone is an extension of an existing AWS region, offering select AWS services and enabling the running of latency sensitive applications near users. It provides a robust connection between local workloads and broader AWS regions, facilitating easy access to in-region services through familiar APIs and toolsets. So basically local zone is a newer feature which helps to bring all the regular AWS services, the common ones around database, storage and compute, near to your local data center. So they will be connected to the main region, and then you can deploy some services around in your data center which will provide ultra low latency to your applications. So some applications, if they need very high like very low latency and very fast performance, then you can deploy those services in your local data center using this local zone feature. Next is AWS wavelength. So this offers single-digit millisecond latencies to mobile devices. So AWS wavelength enables applications that need very low latency for mobile and end-user devices. You can deploy applications to wavelength zones. So developers can deploy their applications close to users within the telecom providers' data centers at the edge of 5G networks, embedded in telecommunication data centers at 5G edge. So wavelength zones are specifically designed to leverage the high speed and low latencies of 5G networks. So this is specifically helpful in use cases. Let's say you want to, let's say you are playing some game on your mobile phone. So that mobile phone will be connecting to the network through the 5G network, right? So in those cases, you have this feature wavelength where AWS directly works with 5G telecom provider, wherein they put their hardware and infrastructure along with their 5G networks, so the latency improves a lot. So this is specifically, as I mentioned, helpful in low latency apps. Let's say, especially if those apps are running on 5G networks like mobile phone and all. So this feature will be especially helpful in those scenarios. So AWS has partnered with those telecom provider to put their services like compute, storage, databases, and ML inference in the telecom providers, like co-locate with them. So it offers seamless access to AWS services in the region. So despite being at the edge, so we say edge whenever we talk about edge networks. So let's say mobile networks, 5G, those are called as edge networks. So despite being at the edge, these zones allows full access to comprehensive range of AWS services, and it is ideal for gaming, live streaming, ML inference, AR, VR, virtual reality, augmented reality, and applications requiring ultra low latency can significantly benefit, enhancing user experience in real-time interactive applications. Minimizes latency to connect to applications. So by bringing AWS services to the edge of 5G networks, wavelength reduces the latency usually experienced when connected to cloud applications. Reduces network hops and latency over 100 milliseconds. So traffic reaches servers in wavelength zones directly within the mobile provider's network, avoiding the delays that occur when traversing the internet. So next feature is AWS Outpost. AWS Outpost extends AWS services, infrastructure and operating models to any data center, co-location space or on-premises facility. AWS Outpost utilize the same interfaces and infrastructure you use in the AWS cloud, enabling seamless operation across cloud and on-premises environments. AWS Outpost offers a truly consistent experience whether working in AWS cloud or on-premises, facilitating easy management and integration. Outposts are ideal for environments that require cloud connectivity but also need to keep certain workload on premises. So basically this feature helps you like on your data premises to install same software as we see in AWS cloud, specific to EC2, RDS and S3, and once you install the same user interface and same software on your own hardware, you can access the data center applications or low latency apps via that. So this is housed on your on-premises facility and it mirrors what is there on the cloud. So this will support, it will offer the same set of AWS tools, APIs, and it extends the AWS cloud. So this is basically you extending AWS cloud to your on-premises data center. And it is slightly different from AWS local zone. Local zone is basically you extend AWS region to nearest to to data centers which are owned by AWS. So it will offer there are some more local zones which AWS publishes, and if you deploy your applications to local zone, it will improve the application performance much higher. But this is basically you extend to your data center, not to the. So this one, in this case, you own the data center, but in the local zone, AWS owns the local zone. And this is specifically for a data center. The perimeter, the boundary is data center, and applications which belongs to a data center. Local zone is more towards customers who are nearer to your wherever you have housed your applications or the databases. So the AWS Outpost is perfect for applications that require immediate data processing or are sensitive to latency by remaining closer to data centers, data sources and users. So in this case, you don't have to traverse the internet because you are basically installing AWS cloud onto your data centers. Okay, AWS points of presence. So AWS consists of global points of presence network for CDN, Cloud Distribution Network, DNS, and AWS Global Accelerator. AWS operates points of presence hosting Amazon CloudFront, Amazon Route 53, and AWS Global Accelerator to optimize edge networking. There are over 410 points of presence in 90 cities across 48 countries. And this extensive edge network includes edge locations and regional caches, ensuring global coverage. Each point of presence is isolated for enhanced reliability, and this isolation prevents failures in one point of presence from affecting others, ensuring robust global network performance. Pairing with thousands of telecom carriers globally. So AWS network is highly connected for optimal performance. Pairing with major tier 1, tier 2, tier 3 telecom providers or the carriers. High capacity AWS network backbone. So edge locations are linked to AWS regions via high capacity redundant fiber network, enhancing content delivery and acceleration. So this is the global diagram of the edge locations and multiple edge locations and regional edge caches. So here in the picture you can see that these are all edge locations, and the purple ones are multiple edge locations are located in that, and then you have regional edge caches, which is used for your CloudFront distribution CDNs, and this is other ones are used for other features like global accelerator and all. So basically this will be connected nearby AWS regions or availability zones, and if your applications travels via these networks, what will happen is it will be much faster. The application will experience faster response times. So cloud security at AWS. So cloud security is the highest security priority for AWS. So AWS prioritizes security, helping organizations leverage the cloud scalability and flexibility securely. Security built into cloud infrastructure. So foundational services and built-in security are core to AWS cloud infrastructure, enabling tailored security measures. The benefit for AWS customers use a network architecture built for the most security sensitive organizations, offering security without the cost of physical maintenance. Cloud security mirrors on-premises security but eliminates the need for physical hardware management, utilizing software-based security tools. Lower cost, high security. So AWS clouds allow scaling and innovation within a secure environment at lower cost than on-premises solutions. Shared responsibility model. AWS ensures security of the cloud while customers are responsible for security in the cloud, maintaining control over their resources. Tools and features for security. So AWS offers extensive security tools and features, including network security and data encryption, to meet security objectives. So I have listed few of the very popular security tools and features which you can leverage. Continuous audits and certifications. AWS environments undergo continuous auditing to maintain security standards, with various tools available for asset inventory and compliance reporting. Next AWS cloud compliance. Robust controls for security and data protection. AWS offers comprehensive controls to ensure security and data protection in the cloud. Shared responsibility model. Compliance is a joint effort between AWS and its customers, emphasizing the shared model for security. Access to security controls and best practices. Customers can leverage AWS security practices and controls built on its infrastructure for their operations. Compliance with major assurance programs. AWS adheres to significant standards and programs like SOC, SOC2, SOC3, FISMA, DIACAP, FedRAMP, PCI DSS Level 1, ISO 9001, 27001, 27017 and 27018. So SOC is Service Organization Control. Then FISMA is Federal Information Security Management Act. DIACAP is Department of Defense Information Assurance Certification and Accreditation Process. Then FedRAMP is Federal Risk and Authorization Management Program. And PCI DSS is Payment Card Industry Data Security Standard. It's used for all credit card transactions. Then we have ISO, which is International Organization for Standardization. And 27001 is Information Security Management System. Then 27017 is for security controls for cloud services. Then 27018 is for the protection of personally identifiable information (PII) in public clouds. And finally, ISO 9001 is for the quality management system. Extensive documentation and third-party attestations. AWS provides detailed information about its IT controlled environment through white papers, reports, certification, accreditations and attestations from third parties. Accessing AWS services. So first one is AWS Management Console. So you can access and manage Amazon Web Services through AWS Management Console. which is a simple and intuitive user interface. You can also use AWS Management Console mobile application to quickly view resources on the go. Then AWS Command Line Interface. The AWS Command Line Interface, AWS CLI, is a unified tool to manage your AWS services, and with just one tool to download and configure, you can control multiple AWS services from the command line and automate them through scripts. Finally, software development kits, SDKs. So software development kits simplify using AWS services in your applications with an application programming interface APIs, which are tailored to your programming languages or platform. So we will start always with Management Console. Then if you have some automation or scripts, we use this one. And finally, when we do application integration and automation, we have software development kits, SDKs, which are available for most of the popular languages like Java, Python, Go, Ruby, and others, JavaScript, etc. And that's all. Thanks for watching.